Hello, everyone. We're Group 7. We're doing the Autonomous Vehicle Challenge competition. So our update starts with the jira sprint. So this week we're trying to do a little manufacturing of the chassis, more of the reporting content getting filled out. We'll do some coding and testing of that code, and then diagrams, flow charts, and those types of things for the report and for the software implementation. We have some parts that we're still waiting on, including the motors, encoders, and motor driver. Parts that have arrived are the GPS, so we've made some progress with the GPS. The report is getting filled out, but we're a little bit behind as far as getting the work that we've been completing put into the report. So we'd like to keep up on that so we don't do that all within the last week or so. And not pushing it out, so we have to do it over the break. So we've got some sections done, but we need to do a little bit more of the more recent work. For the wiring diagram, here you see we did it in Microsoft Visio, so it'll be a little bit easier to edit, where we have two Arduino set up communicating from a transfer and receive through a transfer to a receive pin from Arduino to Arduino. We've incorporated GPS, rotary encoder, and motor driver. Eventually we'll have the motors on here as well, so we can show how those motors are wired into that motor driver. For the GPS sensor, it also has a magnetometer built in, so basically you're able to find the angle, your absolute bearing, so that's your angle off of the magnetic north. And we'll use GPS location in that value, that bearing value as well in our software. For the motor driver, it hasn't arrived yet, so we're going to need to figure out eventually, we're working on some proper integration of the motor driver onto the slave microcontroller. And we'll need to try and figure out some circuit protection for this, because the motors have a much higher amperage requirement than does this motor driver. So we might run into some issues there, but essentially this thing is going to allow us to control the speed and direction of the two motors that we want to control. The coding flow chart, as we mentioned, we have two Arduinos that we're using. So the setup on the master side, we'll get some of those initialize the location and bearing, and then we'll calculate some waypoints. So the rules say we have to stay outside of a boundary. So if we know the corners of that boundary, we can calculate the waypoints that we want our robot to head to. And in order to implement this, we're constantly reading on the loop side location and bearing, checking the distance to the waypoint that we want to be at. And if we have within some tolerance, we can increment to the next waypoint and start heading towards that one. And if we're ever off of our desired bearing, so if we're headed in the wrong direction, is basically what that means, then we can calculate an error value. And then, based on how far we are away from that point, we can tell if we're approaching a turn or not, so we can change the speed of the robot accordingly. And so we constantly are collecting that data and sending it over to the slave side of things. And so on the slave side, we have we're going to initialize, the hardware and all that stuff. So motor driver, the motors. Then we're going to get 3 initial data points. And then from there, we can implement the PID algorithm with those 3 initial data points. And so we'll read data from the master side of things, incorporate the PID algorithm where we would utilize that error value that's coming over. And then the flag value, we can adjust the velocity. So change in speed and direction. So some of the work on that we've done, you can go onto Google Earth and you can get some sample latitude, longitude points anywhere on Earth. So that's what we did here. This is parking lot to the football stadium. And then we use Tinkercad so we can work without having an Arduino constantly plugged into our laptops. So that was pretty useful. And the result of that code is on the bottom right. You see the gray path, which is defined by the points which were calculated to be outside the boundary. And then the orange path is the given waypoints with one additional point that's near where the robot is expected to start and finish. So some other progress are still needed to do some manufacturing on the chassis, so we still need to accomplish that. We're going to go through motor analysis and selection a little bit more carefully this time, mostly because of the issues with the current motor and the motor driver current not really matching up very well. So we'll have to dig into that, and then we'll incorporate a system model similar to the one in the bottom left, where we can use that to implement a PID analysis and design maybe a PID controller that works well for this competition. With that, are there any questions?